Hey everyone, welcome to STEAM Club. My name is Ms. Francis and today I'm going to be leading you in our TikTok science activity. Now before we begin, make sure you have a clean workstation and that you print out our worksheet to go along with the activity. This is going to help you follow along because it will list out the steps. We also want to make sure that we put our hair up, so I'm going to go ahead and do that now. And we want to take off any jewelry that we might be wearing and make sure that our clothes are relatively form-fitting. We just don't want anything to get into our activity. Also, we will be using food coloring, and food coloring can stain, so just, don't wear your favorite shirt or anything like that. You can also use an apron. So once we're ready to go, we can start by watching that very first TikTok video, and then we can get started. So as you saw in that video, we'll be making elephant toothpaste. Now just a few things. In that video, they use some strong chemicals. They use 35% hydrogen peroxide and they use potassium iodide. Now both of those chemicals are a little too intense for us to be using for educational purposes, and you would also need things like safety goggles and a lab coat and gloves to protect yourself. So in order to make the experiment a little more kid-friendly so we can be doing it in our own homes, we're going to be replacing 35% hydrogen peroxide with 3% hydrogen peroxide, which you can get at any store. People use it to disinfect cuts, they use it to clean scrapes and burns. It's really an easy thing to find in the store. So we'll be using 3% hydrogen peroxide, and then instead of using potassium iodide as a catalyst, and we'll talk more about what a catalyst is in a second, we're going to be using yeast. So for our materials, we'll need a plastic bottle, we will need a bowl or a cup of some sort, we'll need 3% hydrogen peroxide, a packet of yeast, which is our catalyst. We will also need liquid dish soap. You can use any dish soap. And we will need some warm water, a 1/4 cup of warm water. When you heat this water up, do it in small intervals, so like 10 seconds at a time, because since it's only a 1/4 cup, it heats up really quickly. So if you overheat it, then you won't be able to use it with the yeast, because yeast is actually a fungus, kind of like a mushroom. And so when we add water to it, the fungus creates carbon dioxide. But if the water is too hot, it will actually kill the yeast. So we want to make sure it's warm water, not hot water. And we want to make sure it's not too cool, because if it's too cool, then the carbon dioxide won't be released and it won't help us with our experiment. You'll also need a funnel. This will help you fill up the bottle, and then you'll need some food coloring just for fun. So let's get our materials together and then we can begin our experiment. So like I said, it helps to have the worksheet in front of you because the steps are listed on here. So if we look at the procedure, under step 1, it says in the bowl, or in my case I'm using a cup, mix the packet of yeast with the warm water and allow it to activate for about 5 minutes while you complete the next step. So I'm going to take my packet of yeast, again this is a fungus, I'm going to pour it right into my cup. We're going to use the whole packet. Then we're going to take our warm water. Now again, you need a 1/4 cup of warm, not hot water. So I'm just going to double check my measurement here. Yep, that's about a 1/4 cup. I'm going to make sure it's not too hot. It's nice and warm, it's perfect. And I'm going to pour it into my cup. I forgot a spoon. I'm going to grab a spoon. And we're back. I have my spoon, so I'm gonna mix this up. It's gonna kind of look like muddy water. I'll show it to you in a minute. And you might see some bubbles. The bubbles are because of the carbon dioxide that's being released by the yeast. So carbon dioxide is an air that's actually what we breathe out. So the same thing is happening here. Just like we breathe out carbon dioxide, the yeast is breathing out carbon dioxide. So this is going to act as our catalyst. This is going to make our chemical reaction happen. So just stir it up, make sure everything is mixed from the bottom. Got some stuck to the spoon here. And it should look about like that, kind of like a like a dirty milk. You're just gonna mix it up nice and good, and we're gonna set this aside to let it activate. So we want all of the yeast to go ahead and dissolve in the water and release that carbon dioxide. So we can put this to the side for now and move on to the next step. So step 2 says in the bottle, gently mix the hydrogen peroxide, dish soap, and a few drops of food coloring. So if we look at our materials, it says we need 1/2 cup of our 3% hydrogen peroxide. So I'll just take our container here and measure out 1/2 cup. And make sure you have an adult help you with this so you can make sure that your measurements are correct. All right, I've got a 1/2 cup here, and I'm going to use my funnel to put it into the bottle. Okay. Next, we need our dish soap. So for dish soap, we need 1/4 cup, 1/4 of a cup. All right, and once again, we're going to use the funnel. Now, dish soap is thicker than hydrogen peroxide. It's more viscous, so it flows more slowly, so this step will take an extra second. After the dish soap, we're going to add the food coloring, and you can pick any color you want, and feel free to mix colors, right? Make it a little more fun. Okay, I think that's enough of our dish soap. Let me make sure it's not stuck in our funnel. Looks like we're good to go, so I'm going to set this aside. I'm going to add food coloring. I'm going to use green food coloring, you know, because 4-H colors. So I'm going to add 5 drops, and then I'm going to stir it up just by spinning the bottle like this. If you're using a cup, you can use a spoon to mix it, but since we've got a bottle, we can just swirl it around. I want it to be a little bit of a darker green, so I'm going to add 2 more drops. Okay, we can put the lid on our food coloring. And stir, stir, stir. So step 3 says, when you're ready to do the experiment, that means that everything is mixed up and ready to go, you're going to quickly pour the yeast mixture into the bottle. So it's only been probably about 3 minutes since we mixed the yeast. So I'm going to give it another stir, make sure everything is fully dissolved. Make sure there's not any stuck on the spoon. You know, yeast is actually what we use in bread, and it helps bread rise because, you know, it's releasing that carbon dioxide like we talked about, and those bubbles get trapped in the other ingredients in the bread, and it helps make it more fluffy, it helps lift it up. So yeast is not only great for science experiments, but it's also great for baking. I mean, if you think about it, baking and cooking is like a giant science experiment, right? Like you're mixing together ingredients and you're getting different things out of it. So just kind of cool. Yeast is often used in the kitchen. All right, I think it's nice and mixed. So I'm gonna make sure that everything is off of my tray except for my bottle. This is the fun part. We're going to take our funnel, we're gonna put it in the top, and when you're ready, you're gonna quickly pour the yeast mixture into the bottle and pull the funnel away. Okay, so it's gonna be like 1, 2, 3. Are you ready? Here we go. 1, 2, 3. This is why we have a tray. Oh my gosh, look at it go. And this is why they call it elephant toothpaste. And you can actually touch the foam. It's safe to touch, and you'll notice it's warm. That's because the reaction that's happening here, this chemical reaction, is an exothermic reaction. That means that it gives off heat. Now, any chemical reaction that feels cold is an endothermic reaction because it's absorbing the heat. So let's talk about what's happening. Let me get a paper towel, and then we'll talk about what's happening. Okay, so now that I can clean off my hand, we can discuss the science behind what's really going on here. Okay, so hydrogen peroxide has a chemical formula of H2O2. that means it's 2 hydrogen molecules and 2 oxygen molecules. So what's happening is over time, hydrogen peroxide will decompose. That means break up, dissolve into 2 different things. It turns into water, which is H2O, and oxygen. So this happens over time, right? Like over a really long period of time. So what's happening is the yeast is acting as a catalyst. And a catalyst is just something that speeds up the chemical reaction process. So in this case, the catalyst, yeast, is speeding up the decomposition. So that way it's happening much more quickly than it usually would. So when we add yeast, which is our catalyst, we're just making this reaction happen much more quickly. And again, this is an exothermic reaction. Because it's giving off heat. So you can play in the foam, you can play in the elephant toothpaste as much as you want. You might still have some liquid in the bottle. That's just from, that just means that there was more liquid than yeast. And it still feels really warm. I don't know about yours, but it feels really nice on my hands. Again, food coloring is in here. So if you put a lot of food coloring, it might dye your hands different colors. Just keep it away from your shirt and you'll be fine. We can get cleaned up from this activity, and then we can watch the next TikTok and start our next project. So as you just watched in that last video, we're going to be moving on to our magic milk activity. For this activity, you're going to need about a half cup to a cup of milk, depending on what size bowl or plate you have. I'm going to just be using a plate that has some edges so you can get like a nice shallow layer of milk. You'll also need food coloring. It's a lot of fun if you have multiple colors to choose from. So I've got red, yellow, green, and blue. You will need some Q-tips, and then you'll need some dish soap. Now, as far as the milk goes, you can use any kind of milk. It could be 1%, 2%, or whole milk. It doesn't matter. But because this activity is really fun to watch up close, I'm actually going to move the camera a little bit closer before we start our activity. Now that we're a little bit closer, we can start our activity. So step 1 on our worksheet says to pour milk into the bowl. So again, I'm using a plate just because it's a little more shallow and will have more surface area. And you just want a nice layer, so it's a little bit, so you have like a little bit of a layer of milk. Step 2 says place a few drops of food coloring near the center of the bowl or the plate. So I'm just going to add some different colors in a few different spots. I'm going to put some red over here. Oh, it doesn't want to go. There we go. All right, there's a few drops of red. Notice how it's staying in one spot. It's not spreading everywhere. We'll talk more about that and why that happens later on. Put some yellow here. Make a little happy face. And we'll add some green. And then some blue over here. All right. So step 3 says dip a Q-tip in dish soap and then dip it in the center of the milk. But before we do that, I want you to take a plain Q-tip with no dish soap on it, and I want you to poke the milk and see what happens. Don't stir it around, just poke it. Nothing really happened, right? Maybe there was a little shake and the colors moved a little bit, but that's not as interesting as we're looking to make this happen. So take your other Q-tip, or the other side of that one, and put a little dish soap on there. Then touch it to the middle and see what happens. It's magic milk. And you can keep moving it around and watching those colors change and move. And they'll just keep on mixing. So let's talk about the science of what's actually happening here. So if you've ever seen a bug glide on water, you might have wondered how they do it. Well, they do it because of surface tension. So surface tension happens because liquid particles are attracted to each other, so they want to stay real close. That's why if you belly flop into a pool, it's going to hurt pretty bad because there's surface tension. So it's almost like you're hitting the solid ground. So surface tension is because the liquid particles are attracted to each other. That's why when we put the food coloring on top of the milk, we see that the food coloring mostly stays in that one spot. Now when we add liquid dish soap, what's happening is the soap acts as a surfactant, which means that the liquid dish soap is reducing the surface tension of the milk. It's also reacting with the fat in the milk. So there are molecules in the dish soap that are attracted to fat. This is the same reason that dish soap helps get grease off of plates and pots and pans, because those molecules are attracted to and absorb fat. So as long as there's fat in the milk, this will continue to happen. So it seems like all of the dish soap has run out on my Q-tip because the milk isn't moving around anymore. So I'm gonna add just a little bit more, and we're gonna see if we can get this activity to keep going. See, the colors are still moving. That's because there's still fat in the milk. Now, when everything stops moving, that's because all of the fat particles have come into contact with molecules from the dish soap. Now, it would be interesting to try this out with different types of milk. So we have 1% milk and 2% milk, and then we have whole milk. Now, the difference between these types of milk is the amount of fat that's in them. So 1% milk only has 1% of the fat from the milk in it. 2% milk has 2% of the fat. Whole milk has all of the fat. So if you try this with 1% milk, the results might be very different than if you tried this with whole milk. That actually might be a really cool science project to try, comparing different types of milk and how much fat they have and how it reacts with dish soap. So keep playing around with these colors. See how long you can get them mixing. It looks so cool. It looks like marble. But after we finish this, we can dump this down the sink and we can start on our next activity. So as you saw in that TikTok video, our next project is Silly Siphon. For this one, you'll need a straw, and I have two here because we're going to do a demonstration with one. You also will need 2 cups, so 2 cups of the same size. You'll need water, and you can go ahead and put the water in one of your cups, and you'll need food coloring. Now the food coloring is not totally necessary, it's really just for fun, so you can see the project a little bit better. So step 1 is to fill one of the cups with water and place it next to an empty cup. Step 2 is to add food coloring to the water and stir it. So I'm going to do green again, another 4-H color. Just gonna add a few drops. Again, this is just so you can see what you're doing. So you can add as much or as little food coloring as you want. But remember, food coloring does stain, and we will have to put our fingers in the water. So if you add too much, you're gonna walk away with colorful fingers. I'm just gently stirring it because this cup is really full. So the very next step is to submerge the entire straw in the water, bendy side down, ends pointing up. Now, if we have a full-size straw, we're not going to be able to submerge the whole thing, so we're just going to put as much as we can of it into the water, with the bendy side pointing down, ends pointing up. So the part that you would normally put your mouth on to drink, that's going to be totally in the water, so that way the straw is filling with water. Then, with it in the water, we're going to put our finger over the opening. We're going to put our finger over both ends, and we're going to flip the straw over so the bendy part is over the edge. Actually, let me spin this around. So the shorter end is going to be over the empty cup, and the longer end is going to be over the cup with the liquid in it. Okay, so step 5, with your fingers over the holes, flip the straw over so the bendy part is over the edges of the 2 cups, and one end of the straw is in each of the cups. Then remove your fingers and watch what happens. So we're going to do this all in one motion. So if we go like this, Nothing happened, right? So the reason nothing happened is because the length of the straw. And we'll talk more about that in the science behind why a long straw doesn't work in a little bit. So your other straw, or if you only have one, you can use the same one, but I'm going to use this as a demonstration. So I'm going to use a different straw. We're going to cut the long end so it's the same length as the short end. Then we're going to pull that bendy part out and we're going to bend it. So it's going to be about the same. It's going to look like a V. Now let's start over. So we're going to submerge the entire straw in the water, bendy side down, ends pointing up, and let it fill with the liquid. I can still feel bubbles escaping, which means the straw is still filling up. So I'm going to give it a second. Then we're going to put our fingers over the holes again with it still in the water. And then we're going to flip it and let go so one end is in each of the cups. Oh, it's filling up. There it goes. Now, if it doesn't work the first time, just keep trying. As long as the straw is about equal on both sides, it should fill. Now it's moving kind of slowly. Oh, my siphon stopped. Let's see if we can get it going again. Let's dip it in so it's fully submerged. Cover the holes and then flip it. See, I couldn't get it to work a second time. Let's try again. Sometimes science works, sometimes it doesn't, right? It's usually just we made a mistake in our process, but we can always try again. Is it going? It's going really slow. Keep trying until you get it. And if you even get a little bit of water in the other cup, I call that a success. So let's talk about the science behind what's actually happening here. Let me grab a paper towel because this water is very cold. So what's happening is when the liquid is sucked up the tube, so the straw, when it's sucked up, it goes over the hump between the two cups and it starts flowing down. Now, two things are acting on the water. First of all, gravity. Gravity is pulling the water out of the straw and down. But another force is acting on it, and this is the cohesion. This is the cohesive property of liquid. So just like we talked about with the milk and the surface tension, liquid particles are attracted to each other. They like to stay close. So as water is going down, it's pulling more water up, right? That connection is happening. So if you couldn't get your siphon to work, part of the problem could be that there was an air bubble up here that was, breaking that path, keeping the two sides from touching in the middle, because you need to have a complete stream of water in order for that cohesive property of liquid to work. So what's happening again is that gravity is pulling the liquid down and out this side, and the cohesive property of liquid, in this case water, is pulling more water up. And that will continue to happen until the water level gets lower than the end of the straw. So it's actually really interesting because ancient Egyptians used siphons. This is called a siphon. They used them in agriculture, so in their farming. They used it to transfer water from canals to irrigation channels so they could water their crops. Today's cotton farmers also use this in order to water their crops. Another way that this siphon method is used is to empty aquariums. So imagine you have like a really big fish tank and it's full of water and you need to empty it. Well, picking up that aquarium is nearly impossible, right? If it's like a 20-gallon tank, how are we supposed to pick that up? So what we can do is we can use a siphon. Instead of using something like a straw, you'd probably use a hose. And once you get that suction flowing, the water will just continue to flow out of the aquarium to the lower point, so like a bucket or a pool that you're collecting this water in. So it's really interesting how we can use science in our everyday lives to help us with different tasks and make those complicated tasks more simple. So once we get cleaned up from here, we can dump the water out. We can move on to our very last activity. Now, as you saw in that TikTok video, this last activity is all about vision and water and how water can change what you're seeing. So all you need is a glass cup. Now, just like she said, you want something that's curved, a curved glass cup, some water, an index card, and a marker. So I'm gonna go ahead and pour my water into my glass. And then I'm going to draw something on my index card. So you can draw whatever you want. It doesn't have to be arrows like she used in her video, but you just want to make sure that whatever it is, you'll be able to tell if it's swapped. So basically all you're going to do is you're going to put the index card in front of your glass, like away from you with your design facing you, and you're going to move it a few inches back and try and watch for your design to be flipped. Let me get a closer view of this on the camera and then we can see it for ourselves. All right, let's try this again. So I have my design here and we're going to see if we can get, oh, I didn't think it was gonna happen on the very first try. There we go. We can see it's reversing. Now let's talk about the science behind why this happens. So basically, this is called refraction. So when a wave, in this case a light wave, which is what we use to see, when a light wave passes from one medium, like air, to another, like water, it changes speed and direction. So what's happening right here is the light wave is passing through the air to the water, and it's slowing down and changing direction, which is causing our artwork to appear flipped. So this is called refraction, and refraction also happens in your eyes. So everything that we see, our eyes, our lenses are actually picking it up backwards because of refraction. So if this is what reality is, this is what our lens in our eye is picking up. They're picking it up backwards. But our brain is smart enough to know that our eyes are flipping things. So our brain flips it back to normal to help us make sense of it. This is exactly what she explained in that video. So refractive errors, so issues in the refraction in our eyes, can cause vision problems like astigmatism. So the way that they fix astigmatism is they give you glasses or contacts, but basically it's just because the shape of your eye is a little bit different. So refraction is happening a little bit differently, and it's making your vision a little blurry. But refraction is a super fun thing to play around with. TikTok science can be so fun. There are so many projects online for us to watch and then try at home. But remember, if you're trying a project that you see online, make sure you have a grown-up help you, because different projects call for different materials and we want to make sure that we're being safe. So no matter the science project, make sure you have a grown-up there to help you. But thank you for tuning in for our TikTok science. I hope that you guys will join us for our next STEAM Club video. Until next time.